Welcome to Tech with Kaushik. This is part 4 of our complete practice question series for the AZ-305 Microsoft Certified Solutions Architect Expert exam. Choose your answer before the timer ends. Then review the correct answer, explanation, and exam tip. Let us begin part 4. Let us examine question number 138. This question focuses on messaging architecture. Let us first review the situation. A small internal workflow must place XML payloads below 64 kilobytes onto a durable queue. The design does not require sessions, transactions, topics, duplicate detection, or advanced broker features. Which Azure service is the lowest complexity choice? Review each available choice. Option A is Azure Application Gateway. Option B is Azure Queue Storage. Option C is Azure Notification Hubs. Option D is Azure Service Fabric. The correct answer is option B, Azure Queue Storage. Here is the technical justification. Azure Queue Storage provides simple, durable asynchronous queues for small messages and has lower operational complexity when advanced service bus capabilities are unnecessary. A. Application Gateway is a Layer 7 load balancer. C. Notification Hubs sends push notifications to mobile devices. D. Service Fabric hosts distributed applications but is not a queue service. Use queue storage for simple asynchronous work queues. Use Service Bus when enterprise broker features are required. The next item is question number 139. Hybrid virtual machines have intermittent connectivity problems. The operations team must determine whether network security rules allow or deny a specific packet flow. For each statement, select yes if the statement is true. Otherwise, select no. The first statement is, installing Azure Monitor Agent and Dependency Agent and reviewing VM insights is sufficient to identify the exact allow or deny result for the packet flow. Statement 1. The answer is no. Use IP flow verify when the requirement is an explicit allowed or denied decision for a source, destination, protocol, and port. Remember this distinction for the exam. Use Network Watcher diagnostic tools for packet path and security rule decisions. Use VM insights for workload performance and dependency visibility. We will now analyze question number 140. The focus now shifts to identity governance. Consider the following scenario. A single-tenant enterprise application is registered in one Microsoft intratenant. A partner's users must use their existing identities to obtain governed access, and sponsors must be able to approve and periodically review that access. Which design should be recommended? Compare the following options. Choice A, Microsoft Intra Entitlement Management with a B2B Access Package. Choice B, Microsoft Intra ID Protection Risk Policies. Choice C, Privileged Identity Management Assignments. Choice D, Cross-Tenant Synchronization without Application Assignment. The best answer is option A, Microsoft Intra Entitlement Management with a B2B Access Package. Entitlement management can onboard external B2B users through access packages, collect approvals, assign application access, apply expiration, and run access reviews while users retain their home tenant credentials. The incorrect choices fail for the following reasons. B. ID protection evaluates identity risk, but does not onboard and govern partner access to the app. CPIM governs privileged role activation rather than ordinary external application access. D. Synchronization alone does not define the application's access package, approval, assignment, and lifecycle controls. A useful examination rule is this. Use entitlement management when external identities need request, approval, assignment, expiration, and review as one governed process. Now consider question number 141. Consider this scenario. An organization must deploy a standard resource group, web app, and Azure Cosmos DB account to multiple subscriptions. The deployment process must package the resources as a single unit, consistently update them, and natively prevent unauthorized users from deleting or modifying the deployed resources. Complete the deployment architecture design. Statement 1. Package and manage the resources as a single lifecycle unit by using the blank. Choose between Azure Deployment Stacks, Azure Template Specs, or Azure Policy Initiatives. Statement 2. Prevent modification of the deployed resources by configuring the blank. Choose between deny settings, resource locks, or Azure RBAC deny assignments. For Statement 1, select Azure Deployment Stacks. Deployment stacks manage a collection of Azure resources as an atomic unit with native lifecycle and protection features. For Statement 2, select Deny Settings. Deployment stack deny settings provide built-in protection against unauthorized modification or deletion without requiring separate lock management. The key takeaway is use deployment stacks with deny settings to manage resource collections securely and prevent out-of-band modifications. The next key item is question number 142. We are moving to Azure Policy Design. Focus on the following situation. Resources must inherit department and cost center tags from their resource group. New resources must be corrected during deployment, and existing resources must be remediated automatically with least privilege. Complete the Azure Policy Design. The first statement reads, use the blank policy effect. The options for this statement are append, deploy if not exists, or modify. The second statement reads, run remediation by using the blank. The options for this statement are a managed identity with tag contributor, a service principal with contributor, or a managed identity with user access administrator. The correct value for Statement 1 is modify. Modify supports both real-time mutation and remediation of existing non-compliant resources. The correct value for Statement 2 is a managed identity with tag contributor. Tag contributor grants the tag write operations needed without broad resource management permissions. Keep this examination point in mind. Modify policies require a managed identity and role definition IDs that grant only the operations performed by remediation. Review question number 143. Carefully. Begin by examining the scenario. An organization must capture Microsoft intra-user creation and role assignment audit events and persist normalized records in Azure Cosmos DB. Map the two processing stages between the audit log and Cosmos DB. Review the available source items. Source 1. Stream Microsoft intra-audit events to a scalable ingestion endpoint. Source 2. Transform each event and write the record to Cosmos DB. The target positions are Target A, Azure Functions. Target B, Azure Event Hubs. Target C, Azure Notification Hubs. Target D, Azure Event Grid. Map stream Microsoft intra-audit events to a scalable ingestion endpoint to Azure Event Hubs. Map transform each event and write the record to Cosmos DB to Azure Functions. The key reason is Microsoft intra-diagnostic settings can stream audit logs to event hubs. An event-driven Azure function can process those events and write the required document model to Cosmos DB. Exam tip. Use event hubs for streamed diagnostic events and functions for lightweight event transformation and persistence. Let us work through question number 144. This question moves us into identity architecture. Review the scenario carefully. 3 departments need identity controls. Security must review privileged memberships and audit activations. Development applications must retrieve key vault keys without credentials. Test engineers need time-limited administrator elevation. Select the Microsoft Intra capability for each department. Choose the correct entry for every drop-down field. Review Statement 1. For security, use the blank. The available choices are privileged identity management, managed identities, or identity protection. Review Statement 2. For development, use the blank. The available choices are managed identities, privileged identity management, or Microsoft Intra-Connect. Review Statement 3. For quality assurance, use the blank. The available choices are privileged identity management, managed identities, or identity protection. The answer to the first statement is privileged identity management. PIM supplies privileged role governance and auditability. The answer to the second statement is managed identities. Managed identities provide credential-free application authentication. The answer to the third statement is privileged identity management. PIM provides eligible, just-in-time administrative access for testers. Use managed identities for workloads and PIM for people who need governed, time-bound privileged roles. We will now analyze question number 145. Let us first review the situation. An application will run on an expanding fleet of Azure virtual machines. Every VM needs the same permissions to Key Vault, Logic Apps, and Azure SQL. New virtual machines must inherit the identity design without creating new role assignments or storing credentials. Which identity should be used? Choose from the following options. Choice A, a certificate-based service principal. Choice B, a system-assigned managed identity on every VM. Choice C, a client secret-based service principal. Choice D, one user-assigned managed identity attached to all virtual machines. The required response is option D, one user-assigned managed identity attached to all virtual machines. The requirement is satisfied because a user-assigned managed identity has an independent lifecycle, can be attached to multiple virtual machines, and reuses the same role assignments as the fleet grows. The other choices do not satisfy the requirement because A, certificates still require credential lifecycle and secure deployment to the virtual machines. B, each system-assigned identity is unique, requiring additional role assignments for every new VM. C, client secrets introduce stored credentials and rotation overhead. Remember this distinction for the exam. Choose a user-assigned managed identity when multiple resources must share one identity and permission set. Proceed to question number 146. Next, we enter the topic of tagging strategy. Review the situation. Cloud operations requires every Azure resource to carry environment, owner, department, and cost center metadata that can be used in inventory and cost reports. Which governance control should be implemented? The options are: Choice A, Microsoft Intra-Administrative Units. Choice B, an Azure policy initiative that enforces required tags. Choice C, a management group hierarchy only. Choice D, a data catalog populated through custom REST calls. The appropriate choice is option B, an Azure policy initiative that enforces required tags. The reasoning is as follows. Azure policy can require, append, inherit, or remediate tags consistently at management group, subscription, or resource group scope. The alternatives can be eliminated because A, administrative units scope identity administration, not Azure resource metadata. C, management groups organize governance scope, but do not populate operational metadata by themselves. D, a custom catalog adds unnecessary development and does not enforce tags at resource deployment. A useful examination rule is this. Use tags as reportable metadata and Azure policy to enforce their presence and values. Question number 147. Requires careful analysis. Pay close attention to every stated constraint. A 10 GB compliance dataset is read daily. Every object must remain immutable for 5 years, after which it may be deleted but never modified. Read access charges should be minimized. Complete the storage design. For the first statement, store the data in the blank. Select from a GPv2 account using the hot tier, a GPv2 account using the cool tier, or a GPv2 account using the archive tier. For the second statement, protect the container with the blank. Select from a time-based immutable storage policy, a resource lock, or a container public access policy. Statement 1 should be completed with a GPv2 account using the hot tier. Daily access favors hot tier despite its higher storage price, because cool and archive add access or rehydration cost. Statement 2 should be completed with a time-based immutable storage policy. Time-based immutability supplies the required 5-year worm behavior. The key takeaway is select access tier from access frequency, and use immutable blob storage rather than locks when data itself must be worm protected. Question number 148. Scenario. A new application writes business-critical block blobs. Each blob must be protected from change for 1 year, reads must be low latency, and the design must maximize resilience among the listed redundancy choices. Complete the storage recommendation. Review Statement 1. Use the blank. The options for this statement are a standard general-purpose v2 account with immutable blob storage, a standard general-purpose v1 account, or a premium page blob account. Review Statement 2. Configure the blank redundancy. The options for this statement are zone redundant storage, ZRS, or locally redundant storage, LRS. For statement 1, select a standard general-purpose v2 account with immutable blob storage. GPv2 is the current general-purpose account type that supports the required block blob protection. For statement 2, select zone redundant storage, ZRS. ZRS protects against a zone failure, while LRS keeps copies in one data center. Keep this examination point in mind. Immutability is a data protection property. Redundancy separately determines infrastructure fault tolerance. Next, question number 149. The focus now shifts to governance architecture. An organization has 1 root management group, 10 child management groups, and 50 subscriptions. A standard set of custom Azure policy definitions and Azure RBAC role assignments must be applied consistently to all subscriptions while minimizing the number of definitions and assignments. Select the optimal scopes for the governance design. Review each blank and choose the most appropriate option. For the first statement, define the custom policies and roles at the blank. Choose between the root management group, the child management groups, or each subscription. For the second statement, assign the policies and roles at the blank. Choose between the root management group, the child management groups, or each subscription. Statement 1 should be completed with the root management group. Defining custom artifacts at the root management group allows them to be referenced anywhere in the tenant hierarchy. Statement 2 should be completed with the root management group. A single assignment at the root management group propagates via inheritance to all 50 subscriptions, satisfying the minimum assignment requirement. Exam tip: apply Azure policy and RBAC assignments at the highest applicable management group scope to leverage inheritance and minimize administrative overhead. Question number 150. Scenario: 10 developers employed by a partner organization must receive contributor access to a resource group. They must sign in with their existing partner credentials. Which identity design should be recommended? Option A: create cloud-only member accounts for the developers. Option B: create Microsoft Intra B2B guest accounts and assign the Azure role. Option C: create an on-premises forest trust. Option D: create a Microsoft 365 organization relationship. In this case, select option B, create Microsoft Intra B2B guest accounts and assign the Azure role. This is correct because Microsoft Intra B2B collaboration represents the partner users as guests in the resource tenant while they authenticate with their home tenant identities. Azure RBAC can then be assigned to those guest objects. Now consider why the remaining options are unsuitable. A. Cloud-only accounts create separate credentials and lifecycle overhead. C. An ADDS Forest Trust does not create Microsoft Intro identities for Azure RBAC. D. A Microsoft 365 organization relationship controls collaboration features, such as calendar sharing, not Azure Resource Authorization. Use B2B guest identities for cross-tenant Azure RBAC when external users must retain home credentials. The next item is question number 151. Next, we enter the topic of high availability. Review the situation. A mission-critical Azure SQL database requires synchronous replica failover without committed data loss and must remain available during an availability zone outage. Which service tier should be selected? Review the options. Choice A: Azure SQL Database Standard. Choice B: Azure SQL Database Business Critical with Zone Redundancy. Choice C: Azure SQL Database Basic. Choice D: Azure SQL Database Serverless General Purpose. The required response is option B, Azure SQL Database Business Critical with Zone Redundancy. Here is the technical justification. Business Critical uses multiple synchronous replicas and supports zone-redundant deployment, providing the required local high availability and zone failure resilience. The remaining options are incorrect because A. Standard does not provide the required business-critical replica architecture. C. Basic is intended for small low-demand workloads and lacks the required availability architecture. D. Serverless general purpose optimizes intermittent compute usage but does not provide the required business-critical synchronous replica topology. Remember this distinction for the exam. Use business-critical with zone redundancy when local synchronous replicas and zone failure tolerance are both mandatory. Question number 152. Now, scenario. A Windows-hosted .NET service writes temporary files to the local file system and records operational entries in the Windows application event log. Administrators need control of the operating system, but the platform should scale instances and reduce repetitive deployment work. Which Azure Compute option best fits the workload? Choices. Option A, Azure Functions. Option B, Azure App Service. Option C, Azure Virtual Machine Scale Sets. Option D, App Service Environment. The correct answer is option C, Azure Virtual Machine Scale Sets. Virtual machine scale sets provide Windows operating system access, local file system behavior, event log support, repeatable image-based deployment, and horizontal scaling. A. Functions does not provide general Windows operating system access or the required event log behavior. B. App Service abstracts the operating system and does not support arbitrary use of the Windows application event log. D. An app service environment provides network isolation and dedicated app service infrastructure, but still does not grant full OS administration and costs more. A useful examination rule is this. Choose virtual machines or VM scale sets when an application depends on operating system facilities that managed app platforms do not expose. Proceed to question number 153. Developers may create Azure virtual machines, but deployments must be restricted to approved regions and approved VM sizes. Which governance service should enforce these restrictions? Available choices. Option A, Azure Policy. Option B, Azure RBAC. Option C, Conditional Access. Option D, ARM Templates Only. The best answer is option A, Azure Policy. The key reason is Azure Policy can deny deployments whose location or VM SKU is not in the approved list and can enforce the rules consistently across scopes. The incorrect choices fail for the following reasons. B. RBAC determines who can perform actions, not which regions or SKUs their deployments may use. C. Conditional access controls identity sign-in conditions rather than Azure resource configuration. D. Templates standardize deployments but do not prevent users from deploying non-compliant resources through other methods. The key takeaway is use RBAC for authorization and Azure Policy for allowed resource configurations. Now consider question number 154. Consider this scenario. An internally developed application must use SAML single sign-on. Users connecting from locations that are not trusted must complete multi-factor authentication. Which two Microsoft Intra features should be configured? Select 2. Choose every option that satisfies the requirement. The options are: Choice A, Microsoft Intra Enterprise Application. Choice B, Privileged Identity Management. Choice C, Conditional Access. Choice D, Application Gateway. Choice E, Microsoft Intra Connect Health. The required selections are option A, Microsoft Intra Enterprise Application, and option C, Conditional Access. The requirement is satisfied because an enterprise application provides the SAML SSO configuration. Conditional access can evaluate named or trusted locations and require MFA when the connection originates elsewhere. The other choices do not satisfy the requirement because BPIM governs privileged role activation rather than SAML application sign-in. D. Application Gateway does not configure SAML federation or identity-based MFA conditions. E. Connect Health monitors hybrid identity components and does not enforce application access. Keep this examination point in mind. Configure federation on the enterprise application and use conditional access for contextual MFA. The next item is question number 155. We are moving to relational data design. An Azure SQL database stores personally identifiable information. Most users may query the table, but only privileged users should see the complete sensitive values. Which feature should be included? Review the options. Option A, transparent data encryption. Option B, dynamic data masking. Option C, data discovery and classification. Option D, Azure Resource RB AC only. The appropriate choice is option B, dynamic data masking. The reasoning is as follows. Dynamic data masking can obscure selected column values for non-privileged database users while allowing authorized users with the appropriate database permission to see the original data. The alternatives can be eliminated because A, TD encrypts database files and backups at rest, but does not hide values from authorized query sessions. C, classification identifies and labels sensitive data, but does not restrict the return values. D, Azure Resource RB AC manages the Azure Resource plane and does not by itself provide row or column query masking. Exam tip: use masking to limit displayed values. Always encrypted to protect data from database operators, and TD for encryption at rest. Now consider question number 156. Review the situation. Administrators must manage Windows and Linux virtual machines over RDP and SSH without public IP addresses. Connections must use TLS on TCP 443, and users must complete Microsoft Intra MFA before access. Complete the management access design. Statement 1. Provide the interactive connection by using the blank. The available choices are Azure Bastion, Just-in-Time VM Access, or Azure Front Door WAF. Statement 2. Require MFA by applying conditional access to the blank. The available choices are Microsoft Azure Management, Azure Windows VM Sign-In, or Azure Storage. The answer to the first statement is Azure Bastion. Azure Bastion meets the protocol, port, and no public IP requirements. The answer to the second statement is Microsoft Azure Management. Microsoft Azure Management is the cloud application used to govern portal-based management access, including Bastion initiation. Use Bastion for private RDP and SSH transport. Use conditional access to protect the management plane sign-in path. Question number 157. This question moves us into identity governance. Scenario: a web application is single-tenant in one Microsoft Intra directory. Users from a partner tenant need governed access while continuing to use their existing identities. Which recommendation best supports the external user lifecycle? Available choices. Choice A, Microsoft Intra Entitlement Management for B2B guests. Choice B, Microsoft Intra Pass-Through Authentication. Choice C, Microsoft Intra Join. Choice D, Automatic User Provisioning without B2B collaboration. In this case, select option A, Microsoft Intra Entitlement Management for B2B guests. This is correct because entitlement management can invite B2B guests, package the application assignment, collect approvals, apply expiration, and review continued access. Now consider why the remaining options are unsuitable. B. Pass-through authentication validates identities against an organization's own on-premises ADDS and does not onboard users from another tenant. C. Intra-join registers devices and does not grant external users application access. D. Provisioning alone does not establish the complete governed B2B access process. Remember this distinction for the exam. Use B2B collaboration plus entitlement management when partner access needs approval and lifecycle governance. Proceed to question number 158. Consider this scenario. Several internal web apps call AP is published through Azure API Management. Microsoft Intra ID issues the access tokens, and unauthorized calls must be blocked centrally with minimal repeated API code. Complete the authorization design. The first statement reads, grant each client application's delegated or application permission in the blank. Select from Microsoft Intra ID, Azure API Management, or each backend API. The second statement reads, validate the JWT at the gateway by configuring the policy in the blank. Select from Azure API Management, Microsoft Intra ID, or each client web app. The correct value for Statement 1 is Microsoft Intra ID. Client permissions and consent are configured in Microsoft Intra ID. The The correct value for Statement 2 is Azure API Management. API Management is the central enforcement point for the JWT validation policy. A useful examination rule is this. Let the identity provider issue claims, and let API Management validate them before requests reach backend APIs. Question number 159. Next, we enter the topic of data migration. 2 migration paths are planned. A full on-premises SQL Server database will move to Azure SQL Database, and a selected SQL Server table will be reshaped and loaded into Azure Cosmos DB for NoSQL. Map each source to the current migration service. Begin with the following source items. The first source item is full SQL Server database to Azure SQL Database. The second source item is selected relational table to Azure Cosmos DB for NoSQL. The destination requirements are as follows. Destination A, Azure Data Factory. Destination B, Azure Database Migration Service. Destination C, AZ copy. Destination D, Azure Cosmos DB change feed. The first mapping connects full SQL Server database to Azure SQL Database to Azure Database Migration Service. The second mapping connects selected relational table to Azure Cosmos DB for NoSQL to Azure Data Factory. Here is the technical justification. Azure Database Migration Service is designed to assess and execute supported database migrations to Azure SQL. Azure Data Factory can extract a relational table, transform its shape, and load it into Cosmos DB. The key takeaway is use database migration tooling for engine-to-engine moves and a data integration pipeline when relational rows must be transformed into a document model. Proceed to question number 160. Consider this scenario. Web access logs are retained as blobs. At the end of every month, the new log data must be transformed and loaded automatically into Azure SQL Database for reporting. Which service should orchestrate the recurring data movement? Option A, AZ copy. Option B, Azure Data Factory. Option C, SQL Server Migration Assistant. Option D, Database Migration Assistant. The best answer is option B, Azure Data Factory. Azure Data Factory provides scheduled pipelines, blob storage, and Azure SQL connectors, transformation orchestration, monitoring, and retry handling. The remaining options are incorrect because A, AZ copy is a command line transfer tool and does not provide a managed recurring ETL pipeline. C, SSMA is used for database schema and platform migration, not recurring blob-to-database ingestion. D, DMA was an assessment and migration utility, not a monthly data integration orchestrator. Keep this examination point in mind. Use Data Factory for scheduled or dependency-driven data movement and transformation across heterogeneous stores. Now consider question number 161. A logistics company is moving 2 tightly coupled SQL Server databases, OrdersDB and LedgerDB, to Azure. Existing stored procedures begin and commit transactions that update tables in both databases. Which target provides native cross-database transactions while minimizing operating system and database engine administration? The options are: Choice A, place both databases in one Azure SQL Database Elastic Pool. Choice B, place both databases on one Azure SQL Managed Instance. Choice C, deploy each database as a separate Azure SQL Database single database. Choice D, host both databases on SQL Server running on an Azure virtual machine. The required response is option B, place both databases on one Azure SQL Managed Instance. The key reason is Azure SQL Managed Instance supports cross-database queries and transactions on the same managed instance, while Microsoft manages patching, backups, and high availability. A, Elastic pools share compute, but do not provide native SQL Server-style cross-database transactions. C, separate Azure SQL databases do not preserve the required server scope transaction behavior. D, SQL Server on AVM supports the feature, but requires more operating system and SQL administration. Exam tip: use SQL Managed Instance when server-scoped SQL Server features must be retained with pass management. Question number 162. Now, the focus now shifts to Azure SQL design. Scenario. A payment platform requires a single Azure SQL database to survive an availability zone failure. Replica failover must be synchronous so committed transactions are not lost, and the design should use the least expensive listed tier that satisfies the requirements. Which deployment should the architect select? Options. Option A, Azure SQL Database Basic. Option B, Azure SQL Managed Instance General Purpose. Option C, Azure SQL Database Premium with Zone Redundancy enabled. Option D, Azure SQL Database Hyperscale without a zone redundant configuration. The correct answer is option C, Azure SQL Database Premium with Zone Redundancy enabled. The requirement is satisfied because Premium uses the business-critical architecture with synchronous replicas and supports zone-redundant placement, providing zero data loss failover for a zone outage. The incorrect choices fail for the following reasons. A. Basic lacks the required zone-redundant high-availability architecture. B. General-purpose managed instances do not meet the stated synchronous replica requirement at the lowest listed cost. D. Hyperscale must be explicitly configured for zone redundancy and is not the least cost unambiguous choice here. For zero data loss zone failover, choose a synchronous high availability tier and enable zone redundancy. Let us examine question number 163. Begin by examining the scenario. A media laboratory receives multi-terabyte video objects from offices connected to Azure through ExpressRoute private peering. Linux Analytics virtual machines process the objects in Azure. Each object can reach up to 4 terabytes. The storage must remain available through a zone failure, and traffic must not traverse a public endpoint. Complete the storage design. The first statement reads, use the blank for the storage account type. The available choices are standard general purpose v2, premium page blobs, or premium file shares. The second statement reads, use the blank for regional redundancy. The available choices are zone redundant storage, ZRS, locally redundant storage, LRS, or geo-redundant storage, GRS. The third statement reads, use the blank to provide private on-premises connectivity over ExpressRoute. The available choices are a private endpoint, a service endpoint, or Azure Route Server. Statement 1 should be completed with standard general purpose v2. General purpose v2 supports large block blobs and broad blob capabilities. Statement 2 should be completed with zone redundant storage, ZRS. ZRS synchronously stores data across availability zones and maintains regional access during a zone failure. Statement 3 should be completed with a private endpoint. A private endpoint is reachable from on-premises through ExpressRoute private connectivity with appropriate DNS. Service endpoints do not extend to on-premises clients. Remember this distinction for the exam. Service endpoints secure VNet-originated traffic. Private endpoints are required when on-premises clients need a private IP over ExpressRoute. The next item is question number 164. This question moves us into API integration. Scenario. A manufacturer exposes selected HTTP-triggered logic apps to a supplier. The supplier authenticates users with an external OAuth 2.0 provider and has no Microsoft intratenant. Supplier calls require a lower quota than employee calls, and the logic apps cannot be modified. Which Azure service should be placed in front of the workflows? Available choices. Option A, Microsoft Intra Application Proxy. Option B, Azure Front Door Only. Option C, Microsoft Intra B2B Collaboration. Option D, Azure API Management. The appropriate choice is option D, Azure API Management. The reasoning is as follows. API Management can validate OAuth tokens from a configured identity provider, apply consumer-specific rate limits and quotas, and proxy the existing HTTP endpoints without changing the workflows. The other choices do not satisfy the requirement because A, Application Proxy publishes on-premises web applications and does not provide the required API quota model. B, Front Door provides global routing and WAF features, but is not the primary OAuth-aware API governance layer. C. B2B would require guest identities, which the design prohibits. A useful examination rule is this. Use API management when existing HTTP API needs centralized authentication, throttling, quotas, and policy enforcement. Review question number 165. Carefully. Consider the following scenario. Several components of a retail workflow exchange small XML documents. Producers must in-queue work asynchronously, and each message is processed by one worker. Advanced topics, sessions, and transactions are not required. Which listed service provides the required managed queue? Now examine the possible answers. Option A is Azure Notification Hubs. Option B is Azure Queue Storage. Option C is Azure Data Lake Storage. Option D is Azure Service Fabric. In this case, select Option B, Azure Queue Storage. This is correct because Azure Queue Storage provides durable asynchronous point-to-point messaging and can carry a text-encoded XML payload within its message size limit. The alternatives can be eliminated because A. Notification Hub sends push notifications to mobile devices. C. Data Lake Storage is an analytical object store, not a work queue. D. Service Fabric is an application platform rather than a managed messaging queue. The key takeaway is use queue storage for simple, high-scale work queues. Use Service Bus when enterprise messaging features are required. Let us work through question number 166. We are moving to logging architecture. Review the scenario carefully. An Azure SQL database in East US already has one diagnostic setting that sends SQL insights to Workspace A and archives the same category to a standard storage account in East US. Fewer than 5 diagnostic settings exist. A second supported storage account, Workspace B, and an Event Hub's namespace are also in East US. For each statement, select yes if the statement is true. Otherwise, select no. Statement 1. A separate diagnostic setting can archive SQL insights to the second storage account. Statement 2. A separate diagnostic setting can send SQL insights to Workspace B. Statement 3. A separate diagnostic setting can stream SQL insights to the Event Hub's namespace. The answer to Statement 1 is yes. A resource can use another diagnostic setting for a second destination of the same type, subject to the diagnostic setting limit. The answer to Statement 2 is yes. A second setting can target another log analytics workspace. The answer to Statement 3 is yes. A diagnostic setting can stream supported resource logs to Event Hubs in the compatible region. Keep this examination point in mind. One diagnostic setting supports one destination of each type. Create additional settings when the same log category must reach another destination of that type. Question number 167. Review the situation. A telemetry platform captures high-volume JSON events and lands them in time-partitioned folders. Analysts must query the landed files directly and build summarized relational tables. The serving warehouse must store about 50 terabytes and support hundreds of concurrent analytical reads. Select the storage service for each layer. Select the value that correctly completes each statement. Review Statement 1. Store the time-partitioned raw events in the blank. Choose between Azure Data Lake Storage Generation 2, Azure Files, or Azure NetApp Files. Review Statement 2. Store the relational serving model in the blank. Choose between Azure Synapse Analytics Dedicated SQL Pool, Azure SQL Database Hyperscale, or Azure Cosmos DB for NoSQL. The correct value for Statement 1 is Azure Data Lake Storage Generation 2. Hierarchical namespaces and object-scale storage support time-based directories and direct analytical access. The correct value for Statement 2 is Azure Synapse Analytics Dedicated SQL Pool. A dedicated SQL pool is a distributed MPP warehouse designed for large relational analytical datasets and high-concurrency BI workloads. Exam tip. Choose a lake for open files and a distributed warehouse for governed relational analytics at scale. Let us work through question number 168. This is a medium-level challenge. Consider the following scenario. A legacy reporting application uses 3-part names and joins objects across several databases on the same SQL Server instance. The company wants to migrate without rewriting those references. Which two Azure targets preserve the required server-scoped database behavior? Select 2. Identify all valid responses. Choose from the following options. Choice A, Azure SQL Database, Single Databases. Choice B, SQL Server on Azure Virtual Machines. Choice C, Azure SQL Managed Instance. Choice D, Azure SQL Database Elastic Pools. Select Option B, SQL Server on Azure Virtual Machines, and Option C, Azure SQL Managed Instance. Here is the technical justification. SQL Server on Azure Virtual Machines and Azure SQL Managed Instance preserve instance-level semantics and support cross-database three-part name access with the fewest application changes. Now consider why the remaining options are unsuitable. A. Azure SQL Database isolates databases and does not natively preserve all same instance three-part name behavior. D. Elastic pools share compute resources but do not support native SQL server-style cross-database queries with three-part names. For applications coupled to instance-level SQL features, evaluate managed instance before rewriting for Azure SQL Database. We will now analyze question number 169. Begin by examining the scenario. Production administrators must register a Microsoft Intra multi-factor authentication method and must complete MFA whenever they access the Azure portal. A conditional access policy named ProdAdmin.ca targets the administrators and Microsoft Azure management. Complete the identity design. For the first statement, manage and promote MFA method registration by using the blank. The options for this statement are the authentication methods policy, security defaults, or a session control. For the second statement, require MFA in ProdAdmin.ca by configuring the blank. The options for this statement are a grant control that requires multi-factor authentication, a session control, or a sign-in frequency control only. For statement 1, select the authentication methods policy. The authentication methods policy governs allowed methods and supports registration campaigns for modern authentication methods. For statement 2, select a grant control that requires multi-factor authentication. A conditional access grant control enforces successful MFA before access is granted. Remember this distinction for the exam. Use authentication method policies for method governance and conditional access grant controls to enforce MFA for a resource. Now consider question number 170. Consider this scenario. An enterprise has 300 Windows Server virtual machines. Operations needs a central KQL-based view of warning level events from each machine's system event log. Complete the monitoring architecture. Statement 1. Create the blank as the central log store. Select from a log analytics workspace, an event hub's namespace, or a storage account. Statement 2. On each VM, deploy the blank and associate an appropriate data collection rule. Select from the Azure Monitor Agent, the Azure File Sync Agent, or the Dependency Agent only. The answer to the first statement is a log analytics workspace. Log analytics stores and queries collected Windows events centrally. The answer to the second statement is the Azure Monitor Agent. Azure Monitor Agent uses data collection rules to select and forward Windows event logs. A useful examination rule is this. For new monitoring designs, use Azure Monitor Agent and data collection rules rather than legacy agents. Question number 171. We are moving to logging architecture. SQL Insights telemetry is exported to both Azure Storage and a log analytics table. The storage account has no lifecycle deletion rule. The log analytics table is configured for the maximum interactive analytics retention supported by the service. Complete the retention statements. For the first statement, without a storage lifecycle deletion rule, archive telemetry remains in blob storage for the blank. Choose between an indefinite period, 90 days, or 730 days. For the second statement, the maximum interactive retention for the analytics table is the blank. Choose between 730 days, 90 days, or 12 years. Statement 1 should be completed with an indefinite period. Azure Storage retains blobs until they are deleted or a lifecycle policy removes them. Statement 2 should be completed with 730 days. Log Analytics supports up to 730 days of interactive retention. Longer total retention uses long-term retention/archive. The key takeaway is do not confuse 730-day interactive retention with the longer total retention available through Log Analytics long-term retention. Proceed to question number 172. Review the situation. A governance team needs a scheduled monthly inventory of resource creation and deployment operations across one subscription. The subscription activity log will be routed to a service where analysts can retain the records and run KQL queries. Which service should receive the activity log? Review the options. Option A, Application Insights. Option B, Azure Arc. Option C, Azure Analysis Services. Option D, a Log Analytics workspace. The correct answer is option D, a Log Analytics workspace. Routing the activity log to Log Analytics stores control plane events in a queryable table that can support scheduled monthly reporting. The remaining options are incorrect because A, Application Insights focuses on application telemetry rather than subscription deployment auditing. B, Azure Arc extends Azure management to external resources but is not the report store. C, Analysis Services is a semantic modeling service and does not collect the activity log. Keep this examination point in mind. Use the activity log for control plane changes and route it to Log Analytics for retention, KQL, and reporting. The next item is question number 173. Scenario: 2 blob workloads require separate accounts. Workload A needs the lowest latency and highest transaction rate while remaining accessible during a zone outage. Workload B is infrequently accessed, must survive a data center failure, and should minimize capacity cost while remaining optimized for object upload and download. Select the account configuration for each workload. Complete each statement by selecting the appropriate value. The first statement reads, for workload A, use the blank. The available choices are a premium block blob account with ZRS, a standard GPv2 hot account with LRS, or a premium file share account with ZRS. The second statement reads, for workload B, use the blank. The available choices are a standard GPv2 cool account with GRS, a premium block blob account with ZRS, or a standard GPv2 hot account with LRS. For statement 1, select a premium block blob account with ZRS. Premium block blobs provide low latency, high transaction object storage, and ZRS protects availability across zones. For statement 2, select a standard GPv2 cool account with GRS. The cool tier lowers capacity cost for infrequent access, while GRS maintains an asynchronous copy in a secondary region and survives a data center failure. Exam tip: match performance tier to access pattern, then choose redundancy from the required failure scope. Review question number 174. Carefully. Let us first review the situation. 10 containerized applications run in 2 AKS clusters located in different Azure regions. Internet clients need one HTTPS endpoint, automatic failover if either cluster becomes unhealthy, and centralized TLS termination so certificates are not configured in every pod. Which service should front the clusters? Review each available choice. Option A is a regional standard load balancer. Option B is Azure Traffic Manager. Option C is Azure Front Door. Option D is an ingress controller in only one cluster. The best answer is option C, Azure Front Door. The key reason is Azure Front Door provides a global HTTPS endpoint, TLS termination, health-based routing, and cross-region failover. A regional load balancer does not provide the required global HTTP routing or centralized edge TLS. B. Traffic Manager is DNS-based and does not terminate TLS. D. A single regional ingress controller cannot provide cross-region availability. Use Front Door for global Layer 7 routing and TLS. Retain an ingress layer in each AKS region for cluster local routing. Question number 175. Consider this scenario. A company is moving 2 terabytes of files into Azure Blob Storage. The account must support access tiers, remain available when one data center in the region fails, and use the least expensive account type that meets the requirements. Complete the storage design. Statement 1. Use the blank as the storage account type. Select from Standard General Purpose v2, Premium Block Blobs, or Standard General Purpose v1. Statement 2. Use the blank as the redundancy option. Select from Zone Redundant Storage, ZRS, Locally Redundant Storage, LRS, or Read Access Geo-Redundant Storage, RAGRS. The correct value for Statement 1 is Standard General Purpose v2. GPv2 supports blob access tiers and is the recommended standard account type. The correct value for Statement 2 is Zone Redundant Storage, ZRS. ZRS synchronously distributes copies across data centers represented by availability zones and maintains access through a zone failure. Remember this distinction for the exam. Use ZRS for in-region zone failure. Use geo-redundancy when the requirement is regional disaster recovery. Let us examine question number 176. This question moves us into secrets and key design. Review the scenario carefully. A web application reads cryptographic material from an Azure Key Vault. You are evaluating the platform-managed response to an outage of the vault's primary region. Complete the continuity statements. Review Statement 1. The Key Vault service fails over to the blank. The options for this statement are the paired Azure region, another server in the same fault domain, or a virtual machine scale set. Review Statement 2. During platform failover, the blank is unavailable because it changes vault data. The options for this statement are delete, get, decrypt, or list. The answer to the first statement is the paired Azure region. Key Vault maintains a secondary copy in a paired region and Microsoft controls regional failover. The answer to the second statement is delete. Read and cryptographic operations can continue from the replica, but write operations such as delete are blocked during failover. A useful examination rule is this. Design applications to tolerate temporary write unavailability during a Key Vault regional failover. Now consider question number 177. Scenario. A company has 3 on-premises VM workloads. Sales must fail over to a second on-premises site. Finance requires 10-minute recovery in Azure and 7-year retention. Reporting only needs daily point-in-time recovery with an 8-hour RTO. Match each workload to the least cost Azure continuity design. Review the items in the left column. Left item 1. Sales workload, finance workload, reporting workload. Choose matches from the following right side entries. Right option A, Azure Site Recovery only. Right option B, Azure Site Recovery and Azure Backup. Right option C, Azure Backup only. Here are the completed matches. Pair Sales Workload and Azure Site Recovery only. Pair Finance Workload and Azure Site Recovery and Azure Backup. Pair Reporting Workload and Azure Backup only. The requirement is satisfied because Site Recovery provides orchestrated replication and failover for sales. Finance needs both rapid Azure failover and long-term recovery points. Reporting needs backup recovery only and can tolerate the longer RTO. The key takeaway is use Site Recovery for workload failover and backup for retained recovery points. Combine them when both objectives apply. The next item is question number 178. Next, we enter the topic of compute architecture. Review the situation. A stateless full .NET Framework application requires custom operating system dependencies, administrator access to the host OS, and continued service after an entire Azure region fails. The proposed design deploys one app service environment in a single region. For each statement, select yes if the statement is true. Otherwise, select no. Review Statement 1. The proposed design satisfies all requirements. Statement 1 should be marked no. App service does not grant administrators general host OS access, and a single region deployment does not provide regional failure redundancy. Keep this examination point in mind. Choose virtual machines or VM scale sets when host-level access is mandatory and deploy independent instances across regions for regional resilience. Proceed to question number 179. A customer-facing Azure SQL database requires synchronous replica failover with no committed data loss and must stay online during an availability zone outage. Select the lowest cost listed deployment that meets both requirements. Which option should be recommended? Choice A, Azure SQL Database Basic. Choice B, Azure SQL Managed Instance Business Critical. Choice C, Azure SQL Database Premium with Zone Redundancy. Choice D, Azure SQL Database Hyperscale without zone redundancy. The required response is option C, Azure SQL Database Premium with zone redundancy. The reasoning is as follows. Premium with zone redundancy uses synchronous high-availability replicas across zones and avoids the additional managed instance scope when only one database is required. The incorrect choices fail for the following reasons. A. Basic lacks the required replica and zone architecture. B. Business critical managed instance can satisfy similar resilience, but adds instance-level cost and features not required here. D. Hyperscale without zone redundancy does not meet the stated zone outage design. Exam tip. Select the narrowest SQL deployment and synchronous zone redundant tier that meets the workload. The next item is question number 180. A rewritten web application uses about 1 terabyte of relational data only during a monthly close process. Connections are absent for the rest of the month, and the company wants compute billing to stop automatically during idle periods. Which Azure SQL database compute configuration should be selected? The options are: Option A, General Purpose Provisioned vCore Compute. Option B, General Purpose Serverless Compute with Auto Pause. Option C, Business Critical Provisioned vCore Compute. Option D, DTU-based Standard Compute. The appropriate choice is option B, General Purpose Serverless Compute with Auto Pause. This is correct because General Purpose Serverless can automatically pause after inactivity and bills compute per second while active, matching an intermittent monthly workload. The other choices do not satisfy the requirement because A, provisioned compute remains allocated and billed during idle periods. C, business critical adds high availability performance not required and remains provisioned. D, DTU-based standard does not provide serverless auto pause. Use serverless auto pause for unpredictable or intermittent single database workloads that can tolerate resume latency. Review question number 181. Carefully. The focus now shifts to hybrid connectivity. Let us first review the situation. Azure VNets in 2 regions use ExpressRoute to 2 on-premises sites. Each site advertises an internet egress path. Azure workloads must prefer the nearest available site and automatically use the other site when the preferred path is withdrawn. Complete the routing design. The first statement reads, exchange the on-premises default routes with Azure by using the blank. Select from Border Gateway Protocol, BGP, static user-defined routes only, or Azure default system routes. The second statement reads, convergence after a site failure should be handled by the blank. Select from Border Gateway Protocol, BGP, HSRP, or VRRP. For Statement 1, select Border Gateway Protocol, BGP. ExpressRoute uses BGP to exchange prefixes, including controlled default route advertisements. For Statement 2, select Border Gateway Protocol, BGP. BGP withdraws the failed path and selects the remaining advertised path. HSRP and VRRP are local first-hop redundancy protocols. Remember this distinction for the exam. For forced tunneling over ExpressRoute, validate default route advertisements and asymmetric routing behavior in both regions. Question number 182. Consider this scenario. A retailer keeps continuously updated operational documents in Azure Cosmos DB for NoSQL. Analysts need to query the data daily from Azure Synapse without consuming request units or degrading the transactional workload. Which integration should be recommended? Review the options. Choice A. Copy every change through an Azure Data Factory pipeline. Choice B. Use Azure Synapse Link for Azure Cosmos DB. Choice C. Read the Cosmos DB change feed directly from a dedicated SQL pool. Choice D. Load the data by using Polybase against the transactional endpoint. In this case, select option B. Use Azure Synapse Link for Azure Cosmos DB. Here is the technical justification. Synapse Link uses the Cosmos DB analytical store to enable near real-time analytics without ETL and isolates analytical queries from transactional request units. The alternatives can be eliminated because A. Scheduled copies add data movement and can increase operational complexity. C. The change feed is useful for event processing but does not provide the same no-ETL analytical store isolation. D. Polybase is not the native method for querying the Cosmos DB transactional store. A useful examination rule is this. Use Synapse Link when operational Cosmos DB data must be analyzed without affecting the transactional workload. You have completed part 4 of the AZ-305 practice series. Continue your preparation by opening the complete playlist and watching the remaining parts in sequence. Please like this video, subscribe to Tech with Kaushik, and enable notifications for more certification exam preparation content. Share your score, questions, or feedback in the comments. Thank you for watching. See you in the next part.